Kia ora team, today we're going to talk about insulation resistance testing of an installation in accordance with ANZS3000. If you don't know what insulation resistance testing is, or you need some help with the meter or how to use it, you can go back and refer to previous videos. Today we're just going to focus on what is in ANZS3000 and how we go about that test on an installation. First, let's look at ANZS3000 itself, and we have that here. We are in Section 8. Section 8 of ANZS3000 is testing, or it's called verification. And I've already highlighted here Section 8.3.3, which tells us the mandatory tests. And one of those is insulation resistance in accordance with Clause 8.3.6. So this is telling us that we must perform an insulation resistance test on our installation, and also refers there 8.3.6 to the location of what we need to do. So I'll quickly flip down to that. We have it here, insulation resistance testing. You can refer back to this yourself and have a read of what it says in here. But the primary thing that I'm interested in here is that we must stress the integrity of the insulation, applying a direct current at 500 volts. So we're going to do this test at 500 volts, and we're obviously going to use our insulation resistance tester, which is able to put out 500 volts. The next thing that I'm interested in seeing is what is the result that I need. So I'm going to use a 500 volt meter, and what do I expect to see? Section 8362 here, results: the insulation resistance between the conductors of consumer mains and submains and earth and live parts of an electrical installation shall not be less than 1 megohm. So that means 1 million ohms. So when I do this test, a reading of greater than 1 million ohms is a pass. A reading of less than 1 million ohms is a fail. Let's take a look at the test itself. Here you can see I have a switchboard. And it has all the usual things here. We've got our main switch, a couple of RCDs, and some circuit breakers, our neutral and earth buzz bars at the top, and buzz bars down the bottom here for our RCDs. And then we have various sub-circuits running out off screen. The first thing that I'm going to do, remember that the standard just said that I must test between all live parts and all the earthed parts. So everything that is earthed in this insulation will be connected to this buzz bar, which means I need to test between that buzz bar and all live parts. Everything that's live in the installation will be connected to my main incoming phase, which is connected here to this terminal of my main switch. So if I test between that terminal and the earth buzz bar, I must therefore be testing between all live parts and all earthed parts, because they're all connected either here or here. I also need to test between neutral and earth, because in this case, neutral is considered a live conductor. So you'll see here I've got my buzz bar link, my MEN link between my neutral and earth buzz bar. Obviously, if I test for resistance between the earth and neutral buzz bars at this point, all I will get is the resistance of that link. What I actually want to do is make sure that nothing that's connected to the neutral buzz bar is connected in any way to anything that's on the earth buzz bar. So I'm going to need to remove that, and I'll do that now. We need to remove that in order to ensure that we do not have a link between my neutral and earth when I'm testing. Also worth pointing out at this point that this test must be done before the installation is connected to power. Once I've connected the installation to the mains, I never ever want to take that link out. It must stay in at all times. I also cannot do a resistance test while there's live power on the installation. So if I'm building a new installation and commissioning it, I must carry out this insulation resistance test first before I connect any power to my installation. Okay, first step, we are going to test between phase and earth. And here I have my insulation resistance tester that you can see there. In order to do this, I'm going to use one probe with a clip on it and one with just a pointy end, because that's the easiest way for me to do it. I'm going to clip onto my earth buzz bar, onto one of the screws there, and the other terminal The other probe will go on the live terminal of my main switch. So that means I'm testing between everything that's connected to that live terminal, which should be all the phase wires in my installation, and everything that's connected to this, which should be all the earth wires in the installation. I also need to turn on all the circuit breakers. If I do not, I will only be testing up to the circuit breaker. This way, I can test the entire installation at once. I'm testing everything that is connected off this switchboard. So let's push the button and see what happens. Well, actually, I'm going to tell you what's going to happen. I have already put a fault on this installation. So I'm going to show you what a failed test looks like. Remember that I must get at least 1 million ohms or 1 mega ohm. And you can see on the meter there it says mega ohm. So let's see what happens. Push and hold the test button, and you can see I've got 0.099 mega ohms, which is 99,000 ohms. And we can surmise from our ANZS3000, where it said it must be at least 1 mega ohm. This is a failed result. I have found a fault in that installation. What do I do next? Because what I found is that fault somewhere in the installation. Because I'm testing the entire installation with one test, I don't know anything about where that fault is going to be. So what I'm going to do next is switch everything off. I'm going to do that so I can identify which circuit has the fault on it. And I'll do it this way. If I test now between the earth bus bar and this circuit breaker, then I'm only testing what's on the circuit breaker because my breaker is turned off. It's no longer connected to the rest of the installation. So if I push test, we can see we get about 2,000 mega ohms, which is much more than 1 mega ohm. So we can say that circuit is healthy. That's a pass. I go to the next one. Very similar result, 1,900 and something. Next one, 1,800 and something. That's fine. Next one, still 1,800. That's fine. And the very last one, oh, and we can see something happening there. 0.099 mega ohms again, or 99,000 ohms. So I can tell that the circuit that has my fault on it is this one. If this is a real life test, now I've got to figure out what did I connect to that circuit and where is the fault. I'll start going and hunting down my fault. What I can do for now is turn everything back on, except the one that I think is faulty, and I can repeat my test on the installation. And we will see around about that 1,900 mark again. That is a past test. So that just confirms everything connected on these devices here is fine. This one is the faulty one. And I'll just, off camera here, remove the fault that I've put onto the installation. So I've gone out, figured out where my fault is, and I can repeat my test here. And we should see that the test is now passing. See 2,500, plenty high enough with this breaker turned back on where we had our fault. The next test that I need to do, because it's all live parts and earth, that means I need to switch that clip. That's not what I'm going to do at all. I'm going to leave that clip on earth, and I'm going to go from neutral to earth. I'm going to hit the test button. So I'm just going on the neutral bus bar and on the earth bus bar. And I'm getting just over 2,000 mega ohms again. So that's 2,000 mega ohms, 2 billion ohms. That's plenty, much more than I need to pass that test. So that's a successful test. I've now proven that everything that is connected to this installation has passed its insulation resistance test. What I'm going to do next, if this was a real installation, I'll put my earth neutral link back in. And provided I've safely passed the other tests required before I liven an installation, now we're able to liven and start the live tests. And those other tests will be described in other videos. There is one more thing that is worth noting while we do this. We must have the switches that is out in the installation, light switches or whatever, they all must be turned on. This is because if I have any of the switches off, then I'm only testing the installation resistance of my cables up to the switch. But I need to test the entire cables all the way along their length, which means I must have all the switches on. And in the case of two-way lighting, it means that I need to have I need to do the test with the switches in every single possible combination of positions. So with two-way lighting, we have 4 different positions that we could have that in. This is to ensure that we are actually physically testing every conductor that's used in that two-way lighting. That's all we need to know for insulation resistance testing today. Thanks for tuning in.